Yes, children, to continue with coordination compounds, we will start with bonding in coordination compounds now. Okay, we saw isomerism in the previous class. Now let's see bonding. Now, see, now if you have to explain the complex CONH3 6 times 3 plus, what is the state of hybridization of cobalt in this? All these things we have to see, right? What is the geometry of this molecule? What kind of magnetic behavior does it show? Is it paramagnetic or diamagnetic? All such things. Now you know cobalt is having configuration 3d7 4s2. So for the neutral atom, you will draw the box type configuration like this. First you will put 1 1 in each, and then 6th electron, 7th electron, then 4s2. Then when the complex is formed, this cobalt is losing 3 electrons, reaching its 3 plus state. So 3 electrons, how it is removed? 2 electrons from 4s and the lastly filled electron in 3d. These 3 electrons are lost, so you will have now 3d6. 4s is empty. Now this is ground state configuration of CO3 plus, and then now it has to accommodate the lone pair of electrons on the nitrogen of ammonia molecule in its empty orbitals. तो इस CO3 plus को क्या करना है? अपनी d ऑर्बिटल में से कुछ ऑर्बिटल्स को खाली करके देना है. ठीक है? कितने? It needs 6 empty orbitals. How many ever lone pairs are coming? That many vacant orbitals are needed to accommodate these pair of electrons. Because in the bond formation, generally what happens, the atoms which are combining, they will share a pair of electron. But in this case, a transition metal is not providing its electron, but it is accommodating the incoming pair of electrons. So 6 pair of electrons are coming, and how? See here, in the ground state it is having 3d6 configuration, and now these 2 electrons are getting shared with the existing 2 electrons. So they all the 6, they now come in 3 orbitals, and 2 orbitals are made vacant. Okay, now these 2 orbitals along with 1s and 3p, it makes up to 6. 1 2 3 4 5 6. Now 6 lone pairs are getting accommodated in these 6. How? When the D2sp3 hybridization takes place, 6 hybrid orbitals are formed, and each and every hybrid orbital will accommodate a pair of electron in them. So D2sp3 hybridization is taking place in the case of CO3 plus, and the complex will have an octahedral geometry, and it will be diamagnetic. Why diamagnetic? Because there are no unpaired electrons in the metal ion. So it will be diamagnetic. Okay. Now in the hybridization, 4s and 4p are used. Along with that, inner orbital में से 3d में से 2 orbital hybridization में use हो रहे हैं. So it is called as inner orbital complex. And why it is called low spin complex? Because all the electrons are paired. There is no unpaired electron left. If unpaired electron is there, only then spin is possible. Since they are all in the paired state, there is no spin possible. So you call this complex as a low spin complex. Now come to the other example, COF6 3-. Now the same way cobalt you have seen, again CO3 plus, you know this. Now in the excited state of CO3 plus, what is happening, you see. Here what happened? The 2 electrons, it got paired up with the existing 2 electrons, and all 6 of them, they were accommodated in the first 3 orbitals. But now in this case, what they have found, these electrons are not getting paired among themselves. If they are not getting paired, that means 3d is not vacant. Then how will the pair of electrons of fluorine get accommodated? It will get accommodated by taking up 4s, 4p and 2 orbitals from 4d. This is an outer orbital, right? 3d participate नहीं कर रहा है, 4d में से 2 orbitals participate कर रहे हैं. So you call this complex as an outer orbital complex. Now how did they find, or why is it that in this case 3D orbitals are used, in this case 3D is not participating? This was because they found out through different methods the magnetic property of this complex. It was found to be paramagnetic. If it is paramagnetic, then it should be having unpaired electrons, whereas this complex was diamagnetic, right? It was not showing deflection in the magnetic field, whereas this was showing deflection strongly. That means unpaired electrons should be there. So if unpaired electrons have to be there, that means इसको disturb नहीं करना, छेड़ना नहीं है. तो 4D में से 2 orbitals उठाया गया और 4s, 4p and 4d they hybridize to give you sp3d2. यहाँ पे क्या लिखा आपने? d2 sp3 because inner use हुआ था, और यहाँ पे लिखा sp3d2 because outer orbital are being used. Okay, and this will also have the same octahedral geometry, and the complex will be paramagnetic because of the presence of 4 unpaired electrons. So from the magnetic behavior they came to understand that in some cases such pairing is taking place, and in some cases the pairing is not taking place. Okay, so this was purely from magnetic character they could understand this. Same way in the case of nickel, you are having now 3 complexes of nickel. One is with Cl as a ligand, Cl minus as a ligand, Cn minus as a ligand, and carbonyl group as a ligand. Now in the case of Cl as a ligand, see it is 3d8 4s2, then Ni in the 2 plus state. Here in this complex it is in the 2 plus state. So 2 electrons have gone. So you have 3d8. Now in the excited state what is happening? 3d8 remains as 3d8 and 4s and 4p are participating in the hybridization because 4 pairs of electrons are supposed to be coming from 4 Cl minus. So 4 are ready, 4s and 4p will participate. So it is sp3 hybridization. Presence of unpaired electron is there, so it is paramagnetic. And since it is sp3 hybridization, the geometry is tetrahedral. Now you may expect the same thing in the case of Cn minus. But in the case of Cn minus, what is happening? Again 3d8 4s2, 2 electrons have gone, it is 3d8 now. Now these 2 electrons are getting paired and making one d orbital free to participate in hybridization. So because 4 pairs of electrons are coming, 1 d vacant हो गया, तो एक d, एक s और 2 p. तो dsp2 hybridization is taking place, and the molecule is diamagnetic because all the electrons of the metal ion, they are in the paired condition, and the geometry is square planar, right? Now if you consider NiCO4, now this is a neutral complex. In this case what is happening? The same way 3d8 4s2. Now since nickel is in 0 oxidation state because carbon monoxide, it is a neutral ligand, so nickel is showing 0 oxidation state. So what happens? These 2 electrons, 4s की 2 electrons है, वो d में आके pairing हो गई. So 3d completely filled हो गया. Now you are left with only s and p to participate in hybridization. So this is also undergoing sp3 hybridization and will show tetrahedral geometry, and this will be diamagnetic. This is also diamagnetic, this is also diamagnetic, but see the difference. Here एक d खाली हुआ, dsp2 hybridization, and यहाँ पे s की 4s की दोनों electrons d में आके pairing हो गए, and it is showing sp3 hybridization. So it was all because of magnetic behavior. They were able to understand in which case d is participating, in which case d is not participating.